not supposed to be able to hear me right now. And, oh, that's why. Is that why? That's me. Welcome. You guys shouldn't be able to see the stream. There we go. Now you won't be able to hear me. What's up? Oh, my chat's not working on the stream. What's up? Now you should actually be able to hear me, and you're actually supposed to be able to hear me now. That's what happens when you don't turn the, oh, I'll turn the music down. That's what happens when you don't turn the monitor off when you're testing your sound setup before you stream. This is only the 4th time I've ever streamed, so it's not exactly shocking that I would mess it up a little bit. I think I'm gonna start the stream with slow mode off if everyone can behave themselves, because that makes chat a little bit more fun. But as soon as people start misbehaving in the chat, slow mode's coming back on. But welcome everyone. Now you can actually chat to me at the rate of your choosing. Today we're gonna be doing game programming. Yeah, and I'm gonna try to not get too distracted by the chat, basically. That's kind of the goal for the stream. Get ready for chat spam. Yeah, if you spam, you will get booted out of the chat. Start coding. I'm working on it. Yeah, it is written chat is disabled on the stream. I think I need to sorry for the stream internals going on here. Working now? There we go. There we go. Just gonna go through all my camera angles. Welcome to the code. Can everyone see the code on the screen? That's all I gotta check out. Ladies Titan, yes. Your head is big. My head is very, wait, you're Danish? Yeah. I am. I'm in Denmark right now, and it is incredibly warm, and my windows are shut and everything. So, if I get unreasonably warm later in the stream, you know, you guys know why. if I start shining a little bit too much. Okay, everyone can see the code though. Is the font size okay? We're just scrolling through some entity particle stuff. Yeah, the old grader. Yes, it is insane. Yes, everyone can see. Yeah. Oh, I can see I'm streaming at an appropriate time for Danes to be in the chat. Well, anyway, do you use Vim? Yes. Welcome everyone to the stream. I'll actually legitimately start the stream now and start explaining what I'm going to be doing. Today, as you can probably see by the title, we are going to what are we going to do? We're going to add player jumping mechanics, but not actually jumping mechanics. The player is going to kind of I'm going to move the mic a little closer. You guys might be able to see it in the frame, but we're just going to deal with that. I'm going to add player jumping mechanics. Letting the player hover and move vertically in the levels, which is actually an interesting problem to solve because it's isometric, which means that vertical movement is a little weird because I don't see a ton of isometric games with vertical movement. But yeah, that's what we'll be doing today. Yes. I don't think there's anything else I need to explain, actually. I think we're kind of just going to quick start it. Oh, yeah. I have a little... I'll show you guys a little bit of the inside baseball here. I have this that's showing me... Oh, I can't drag things up onto my screen. Otherwise, okay, I would have showed you all the plan for the stream a little bit, but the first thing I'm going to do is I'm actually going to do a small tour of the code, because a lot of stuff has changed since the last time. Since I did that overview, I think it was a couple months back on my channel. And there's changed quite a bit, quite a few things in the code. So let's get started browsing around here. So the biggest change, and stuff that I like mentioned in my last video, but I didn't really go into depth with, was I moved away from the entity component system to like an actual ooh, that's everything. Oops. Okay, man, I'm really an inexperienced streamer. Ooh, thank you for the 10 British pounds, Dempsey. Thank you very much for the donation. I'm being honest enough to understand what you're saying in your videos. Thank you very much. Yeah, FCF, Fuzzy Finder. Oh yeah, also now, man, I'm gonna get really distracted. I do need to get better at streaming. I'm getting distracted while I'm doing it, but all of my dot files, all of my configs are now actually linked in the description. So if you want your Vim to look as beautiful as this, you know, you can go and you can go look in the description, and you'll have everything. The most recent addition to my Vim setup is this, which actually it doesn't look that cool here. Oh, and it just crashed there. Here we go. This is some like code outlining stuff, basically, that will show a current outline of the of the current of the symbols in the code, and make them like easily navigable, which is super cool. What do you use for C++, ZLS? I use CLangD or ClangD. Yes, FCF. This is FCF. I haven't tried Telescope. Yes. Okay, but anyway, so we are going to be going through a basically, like, so we're going to start with a quick overview of the code. So because there's changed a lot of stuff. A lot of stuff has changed. Got to get used to speaking English to you all again. Anyway, focus. The biggest change is that we moved away from an ECS in the code base. But also, as a little update, the engine is now 24,000 lines of code, or not the engine, well, the engine in the game is now 24,000 lines of code, excluding like all of the stuff that I didn't write, like all of these libraries and everything here. So it's gone a little bigger. I think around the last time I went through an overview of the code, it was around like 19,000 or something like that. But anyway, since my last overview, the biggest thing for the third and final time, the biggest thing that's changed is I moved away from an entity component system. So if you don't know what that is, it's like it's a very specific way of organizing entities that you can read about a bit, but it's basically where entities are like just an ID that basically references a bunch of different components that can be enabled or disabled. And components might be like a position component and a velocity component and like a gravity component. You know, you can imagine the system works by like if you have a gravity component, if it's enabled, you apply gravity to the entity. If it's then you have a system that applies gravity to all of the entities with a gravity component. And if it's disabled, then you don't do that, right? And that's how you build your entities. That's how my entities were organized, but I found that it was basically just getting very unruly when I was trying to program. I found that it was I was spending more time thinking about where I should put code than I was spending actually writing the code, and it was just inducing like developer stress, basically. Developer being me. If that makes sense. I think the breaking point was when I was like trying to add some new entities in, and I was just like, I don't know where I should put a bunch of the code that's like very specific to this entity and that I know won't be used for anything else. And so then I just decided to, you know, switch back. Oh yeah, someone was asking, what is the game like? That is a very good question. So if we, oh, this is going to show up on the wrong screen. Yeah. We will really quickly just go and look at what the game looks like right now. That didn't move it onto the proper monitor. Why didn't I move onto the proper monitor? Can I move? There we go. Okay, here we are. So this is, I've taken an earlier branch of the game for this stream, just so that it's not showing any of the new secret things that I've added since my last video. But this is what it looks like right now. It's pretty much what I had in the end of the last video. We're not going to be working on terrain generation today. It's just back to like some little a little randomized almost circle as the terrain, if you guys can see that. Oh, this is actually pretty small. Let me make it bigger. 600 by 900. Uses money to buy a candy bar. Thank you very much, Toby Wong. I will use it to buy a candy bar. I promise you. Oh, here we go. Now it's a little bigger. But this is basically where we were at last time. So we have our 3 plants. We have sunflowers, daisies, and dandelions here. We have this guy, which was the entity that precipitated the component system to object-oriented change. I was trying to add these little shrine things, and then I just couldn't figure out where all of the specific stuff should be. And I was like, I don't really want to keep adding, like, it felt a little silly in a component system to keep adding specific data to specific components for specific entities. Like I had a player component for like player specific stuff that would not be used on anything else, and you know, like a shrine component for this, and it was just getting a little like unreasonably unreadable and unmanageable also in terms of like number of files and stuff like that. So anyway, we got this guy, we have this stuff, we have this little crystal over here that you can break. You can break tiles in the ground like this. You can break plants. And you might be able to hear there's small sound effects actually when you break things. I don't know if you can hear that. You listen very closely right now on the stream, you can hear a little bit that their footsteps. And then, oh, you might be able to hear this sound effect. You can hear it. And then a little beep when you pick up items. The items blink as well. That's basically the branch we're working with. But the problem is, what we're trying to solve today for our little for our robot here is when he goes down in a hole, he can't get up again, and he can't place blocks to help his exit, which is a bit of a problem for him because he can just you know, he can just get stuck down here and he can't do anything. So that's what we're going to be working on. Let me take a quick look at the chat. How work the physics? It's basically just like bounding boxes for physics right now. Which game engine? No game engine. That's why it's 24,000 lines of code for a little demo like that. Diablo feeling, but with flowers. Thank you. That's exactly what I'm going for. That's it. It's actually basically supposed to be Diablo with flowers. Was that GIMP? Yes, I'm an open source daemon. Do you have anything in place to support multiplayer in the future? No, explicitly not. I will not be supporting multiplayer in this, I don't think. At least it's not like, it wouldn't make sense within the gameplay design that I have right now. So, and also makes coding significantly simpler, that I don't have to worry about, you know, separate clients and stuff like that. Is it kind of idle game? No, exactly the opposite. Wouldn't an OOP approach make inheritance a mess? That's a great question, Redstone Ninja. Let's talk a little bit about that. So right now, the way things are structured is I have this, like, it's very traditional OOP. I have this entity structure that is like the, we can actually, ooh, let me use my new Vim plugin. we can take a look at it. So it's got quite a few fields on it. All the stuff for like managing entity position and stuff like that. And then it's got a whole bunch of methods in it that can be, oh, you can't actually see this because it's behind the chat. Let me move it out there so you guys can see all of that. Sorry about that. It's got all these fields, and then it's got all of these functions on it. And so basically it's got all of these virtual functions that are overloaded when, you know, it's like traditional object-oriented programming. These virtual functions get overridden, not overloaded. They get overridden when, you know, when some subclass wants to change behavior. Right now the entity class isn't too large. It's, yeah, about 200 lines of code with a whole lot of comments on it. And then so the entity, main entity, like, controls like a bunch of, you know, it controls standard entity stuff. But as you know, as it pertains to that question about like the inheritance tree and stuff like that, it's not too bad, and I don't think it will be too bad. Like all of those plants, we have entity plant. Oh, there is some like evil, or like, I won't say evil, but I'll say ugly virtual inheritance stuff going on, in terms of like that I want to be able to subclass entities and like a, not subclass specifically, but like have almost like mix-in style things with entity classes. That's what this like entity modeled and entity colored are about. So entity colored is like any entity that can tell you that it has some colors on it, usually used for making like particle effects and stuff like that. So like if an entity implements this, then it's just like, you know, it says that like you can get colors out of it. And then like entity modeled is for all entities that have some model, right? Some like model entity. Yeah, I will actually, you should pin a comment telling people to look in the description for edit. Can I pin comments? I don't know if I can. Yeah, look in the description for editor related stuff. I don't want to have to do this again. If anyone remembers from the last stream, I'm not answering questions. Yes. If you comment, you can pin your own. I'll just yeah, I think, wait, if I understand correctly, entity is like the base object you inherit from? Yes, exactly. Do you think the performance trade-off of OOP is worth it for 2D games? I don't know what you really mean by performance trade-off. Like, I don't. The other reason why I abandoned ECS was because it like you can handle a lot of entities at the same time without problems. Like a lot of what's the word? Like OOP entities at the same time without any problems. Like it's not necessarily, and like virtual functions like and cache destruction and stuff like that, like you're probably not going to experience those problems unless you have like tens of thousands of entities. And how often do you have tens of thousands of entities? Or do you need to be able to support that? Something that would like actually necessitate the speed boost that you might get from an entity component system. Like right now, if we do like, let me see, do we track the number of entities anywhere? All entities. No, we don't track the number of active entities right now. But like, we have monolith as Chad performance. True. I do write my code as a massive monolith. What was I gonna say? Something about, yeah. Right now, all of my entities are just managed into like this fat list of entities. And then they're like thoroughly subdivided up into chunks and stuff like that. But they were before the ECS anyway. It's vast enough. All of my particles are individual entities, and that's, you know, when you run it, it's not because there are like no particles and you're experiencing like some massive slowdown. Like for instance, with let's try something. Tile, sun crystal. Where is it? Oh, that's just going to be the random tick. Okay, let's have this spawn like a lot of particles every time it emits particles. Yeah, say you want to run this on Windows 95. Exactly. There we go. And there's like, you know, there's no slowdown from just having, I know 50 to 60 isn't a lot, but my point is it's easy to handle entities with an OOP. As I program more and more, look at this. The tick time is literally the same as it was before. You know, if we look at that, that's like 0.8 milliseconds. And then if we scroll all the way back up, yeah, it's also okay. It adds a little bit to the tick time, but my point is, just choose the simplest option until you actually need something else. And I feel like I made a mistake in not choosing the simplest option and just going with the OOP from the start. So that's my small use object-oriented programming rant. But anyway, so that was the movement of object-oriented over to ECS. So this also enables some other stuff that I've done since. You can also, the other big entity on the screen, just to look at its like inheritance hierarchy and stuff like that, is the player, which is an instance of mob, which is an entity and a model entity. So a mob is just like anything that has a direction and can, like, you know, you can see interact with stuff. And then that just subclasses entities. So the inheritance hierarchy is just like relatively flat, basically. This is me making like a very flat triangle for the inheritance hierarchy. Yeah. So one of the cooler things that this allowed me to implement was an entity reference type that's like basically a smart pointer to entities. That is also like nullable and stuff like that, that will always go through the level to look up entities to make sure that you don't, because once you move to object-oriented from an entity component system, you end up running into the problem a lot of where do I store entity pointers, basically, or like how do I make sure that if, like, you know, the classic problem of like you have entity A and you have entity B, and entity A is chasing entity B, so it's got like a reference of some sort to entity B, and then entity B takes a portal and goes out of the level, and then entity A now has a reference to an entity that no longer exists. And then, you know, what does entity A do with that? You know, how does that reference get resolved now? And you know, if you store raw pointers from entity A to entity B, then you have a dangling pointer to some freed memory. And that's bad. Your game's going to crash. You could use standard C++ smart pointers, but that might be a little cumbersome and a little bit overkill in a lot of cases. In an ECS, what you do is you have entity A, and not even necessarily only in an ECS, but this is just a solution that you could use that ECS is, encourage. You know, entity A stores the ID of entity B and is always like, entity A needs to find entity B to chase it. So it asks the level, where's the entity with ID 20, right? And then it says the entity is here, or it says the entity is gone, right? But here I have that wrapped up in a nice smart pointer, basically, that stores the level and the entity, so that entities always make sure to ask the level if a level, if an entity still exists by its ID, whenever you're referencing it. So you can see that's used in, where is that used? I guess in interactions it's used. So an interaction is like an instance of smart pointer should have no undue overhead. Yeah, well, this is like, it's like a very smart pointer. It's got a little bit of overhead. It's just an array lookup basically every time. Like it's used here in interactions. So interactions store like, whenever you as the player destroy a tile or a plant or something like that, an interaction gets stored that's like information about what happened, like who destroyed the plant, like who destroyed what, where was the plant, where was it you did the interaction. And that uses an entity ref, because after the interaction happened, the entity might disappear. So that's, I guess, a good example of where it's used. And then I have a similar system set up, of course, for item references, which are, if we run the game again, he's got a consistent and well thought out design for all of the game objects. Consistent and well thought out is not like the first two words that I would use. I would use like, we can just scratch out consistent and well thought out design to he's got a design for the game objects. That's what I've got. Anyway, so you know, the item references are used like when you do stuff like this. You know, when you take the item out of the inventory, and you need to like refer to an item that's still technically in an inventory, even though it's like out of the inventory, if that makes sense. Like you can drop it. Basically, it's a safe way to refer to specific items in containers without breaking things down. Exactly. Okay. So you just got dunked on. You didn't get dunked on. You just, you know, you thought my code was better than it was, and it isn't. So anyway, that's kind of the biggest thing that's changed in the code. Yeah, OP, ref types. I kind of wanted to show off the multi-mesh instancer from my last video, but I think we're probably just going to, entity ref just wraps a pointer. It doesn't allocate. Entity ref wraps a pointer to the current level and an ID for an entity. So it just always looks up through the entity array whenever you need to reference it. And of course you can, you know, get the pointer out of it so that you're not always going through that array if you are doing it in like a safe way, right? So, Tanza, do you do greedy meshing? Yeah, this is all greedy meshed. Where does that happen? Greedy meshing on the chunks actually doesn't happen because it's not really like, it's not really worth it because you're not drawing too many things. But in here, there's greedy meshing and everything that manages the voxel models. Oh, you probably can't see that on the stream. Everything that manages the voxel models is greedy meshed. Like the player is greedy meshed, you know, item meshes and stuff like that. What structure you use for the ID lookups? I use an array. You know, because array fast, not array not fast. So, or like can be variably slow. Exactly. So, now we are actually going to get to the code for today. Do you have to render triangles? Yeah, it's all triangles in the what do you say? Triangles all the way down. Yeah, is this C++? Is this C++? Anyway, that's all the code stuff that I wanted to show off. Chat not asking what language is this timer set right now? Okay, looks like we got a little addition to make. The language, this is C++. My editor is NeoVim. This theme is gruvbox. Any other stuff to add? Wait. Should I just really quickly add it just to Unity bad? Are that good? Is everyone happy now? Everyone understand the point of the stream? There we go. There is no engine. Unity bad. I don't know. English config and description. Yeah. Anyway, now okay. I promised game programming, and we will actually get to game programming. What rendering library do you use? Bgfx. But that's just like a low-level wrapper. A very helpful low-level wrapper. Anyway, we're gonna get to the game programming. So I explained our problem earlier. I'll go through it really quickly again. Basically, not GIMP. I want this window. Okay, basically. Okay, whatever. here's our problem. We got our dude here. He's chilling. He is removing some tiles, and then he falls in a hole. This is bad because now he can't get up. So what we're going to do is we are going to we're going to make the player like fly up. We're going to make him jump, but not actually jump. The stream title is a bit of a lie because what I want for the player is, because he's a robot, there is an in-universe excuse for him having some little like hover boots. So what he's going to do is he's basically going to hover up out of the hole. Also because jumping looks whack and isometric in like the isometric view. So yeah, that's what we're going to do today. He's going to get hover boots. I want them to have particles. I want them to emit light when they're used. I think that's basically it. Thruster boots, exactly. Oh, he could also have a propeller on his head. That's a fantastic idea. Oh, that's a really... Okay, I'm writing that one down. We're not going to add the head propeller yet, but head propeller is a fantastic idea. Thank you, MCAC003. I'm just gonna note that down. Head propeller. Head propeller. This is going down in my my big notebook of important ideas. Oh, sorry, that was probably really loud on the mic. Head propeller is better than boots. Yeah, I do kind of like the idea. A head propeller would be... Yeah, that would be incredibly cute. Okay, but right now our goal is to make the robot fly a little bit. We could add a head... Oh, a head propeller might not be that hard. Okay, the robot's getting a head propeller. What do you plan this maximum height that someone can hover with the boots to be? It's just going to be like, the level is 8 tiles tall right now. Anyway, the first thing we're going to do is we have our player entity here. And what we need to do is we need to make it react on a control press. So we have this control struct that's stored like globally. We have this control struct stored globally, which reads out of this defaults, which has a jump key that's automatically loaded into it off of the keyboard, and that's here. That's an input button. So we can say if global dot controls not up jump is down. Or let's start out. I'll start out by showing you guys that the like an impulse jump just looks really silly in this context. So we'll just add we'll just like add to the Y position whenever you hit something. Let's add gravity times 10 right now. And then well, you know, I'll see you guys, I'll show you guys why. Okay, we need more than gravity times 10. Let's do gravity times 100. I'll show you guys why we need like a hover boot or like a propeller or something like that. That was a crash. Okay, maybe 100 is too much. Oh, we need to add to the velocity. Jeez. Okay, never mind. We're not directly adding to the position. That explains why it has been a couple days since I've looked at this code, and my excuse. Okay, add to the velocity 100. And then we're good to go. Whenever it opens up. And nothing's happening. Why is nothing happening? Is it because... Why is nothing happening? Is pressed. Velocity plus equals gravity. Oh, it's because it's getting sent into the ground. Vertical velocity. Sorry, velocity needs to get... Okay, what is the gravity constant? I'm just using this as a demo. Okay. This is what we're doing. Man, I'm really not on my game today. Is upwards positive or negative? Yeah, everyone saw that. Everyone knew the problem in my own game. There we go. So look, now he can also fly a little bit if you just like spam the jump key. But if we make this jump powerful enough, right? It ends up looking a little silly, basically, is the problem. See? This is why the regular impulse jump like isn't working, because even if you're down in this hole, right, and you're like jumping up, it just looks kind of dumb. I think the robot just like we don't have a ground check in there, but like right, this doesn't look so good. Are you going to apply constant upwards force? Yeah, you need an easing algorithm. Yeah, but with the easing algorithm, I was thinking like, why not add why not add hover boots? But then I decided because of, and his name will go down in history, MCAC003, I decided we're adding a propeller hat instead on top of the robot. So anyway, this is why we need hover boots. So what we're gonna do is, yeah, maybe an acceleration system. That's exactly the plan. So this is, we're just going to basically evolve this. So we're gonna add the jump is down, and then we will add to the velocity and see how that looks, because I haven't really done any like testing, and we're absolutely just going to use like magic constants for this like velocity system. Okay, this doesn't work. Just giving the negative gravity doesn't work. He's not flying anywhere when I'm pressing. So let's add ×5. Yes, welcome to game programming with JDH. Today we're going to be trying out different magic constants. That's a little too fast for some hover boots, but like it's getting there. It's getting there. You can see he's just flying up, just chilling. How about a fuel or battery? Yeah, that's what this bar down here is right now. Technically nothing modifies the robot's battery, but this is like the battery bar. And then I'll probably add like an overlay for like how long you're able to hover, but everything will take battery. Anyway, now a robot can fly as long as you're holding down the space bar. So that's something. So if we tone that down to like, let's say 2.5. Isn't there a leaf on his head already? That's not a leaf, that's just like a little blinker. There we go. A little bit better. I mean, he's also still like running in the air, which looks a little silly. There we go. Yeah, maybe I'll turn it down a little bit. Maybe let's try like 1.5 just because it'll be like slow, basically. Like slow upward movement. There we go. That's something. I think this is maybe the feel that we'll go for. So you can just like really slowly, maybe that's a little too slow. Okay. He's getting 1.8. It's hard to see if he's flying or going up. Yeah, that is the isometric view for it. How about a mini map? There will be a mini map. There we go. So that's what we're working with. So, but now we need to make it feel a little better. So the first thing to do is probably to add like some sort of like startup time. In terms of like, because if you're like what's a game where you use a jetpack? I can kind of only think of like the Halo jetpack, basically. But if you've ever played Halo and you're using like that one jetpack power, it takes like a little bit of time to get like full thrust. So I kind of want to add, or like jetpack joyride or something like that. Yeah. Just need a shadow underneath them. There actually are shadows right now. We would just need to turn up how intense they are. But that's something that I haven't looked in the lighting code in a long time. How do you switch files? Please don't spam your questions, but I'm switching files with a plugin called Fuzzy Finder. You can find the link to all my configs in the description. Add some effect on the feet. You could distinguish flying and standing. Yeah, I think he's gonna have some like little glow or like some little particles under his little boots or something like that. Turn up the intensity of player shadow. Yeah, hold down to boost jump. Yeah, but basically, I'm gonna add like some slight resistance into like the maximum thrust. So what we'll do is we'll add like here's what we'll do. We'll add like a thrust vector. I'll just call it jetpack thrust right now. Actually, we'll say to do on the documentation. So he'll get like a thrust vector, and then what we'll do is we'll add this thrust. Let's just call it thrust right now, or like thrust, what could I call it? Oh yeah, you can't see the screen properly. Spiders, increase font. We'll get a little bigger. But I also need to be able to actually like see the code and stuff like that without it being like way intensely large. Thrust power. Yeah, maybe thrust power. What we'll do is this thrust will be like the acceleration. Oh yeah, the thrust acceleration. Am I spelling acceleration? Man, your English spelling gets really bad when you don't speak a ton of English. Thrust acceleration, which will be like acceleration from thrust added to velocity vector per tick. Why is thrust acceleration a vec3? It's because, like, you know, in the future, if I want to add like other directional thrust, it could just as easily be like, you know, some sideways direction or something like that. So that's why it's a vec3. English is not your original language. No, English is definitely my native language. I live in Denmark now, so I forget, I don't speak a lot of English in my like day to day. So I think it's kind of easy to forget a language if you're not using it too much. So what we're gonna do is we'll define two constants up here, like a thrust power, which will be the actual acceleration, and that's gonna be our 0.0056, or what we'll do is the inverse of gravity times 1.8f. That's our thrust power, and then our thrust max is gonna be like actually we'll do it like, oh sorry, that should be our thrust max, and then the thrust power is like that, I think. So then what we're gonna do, what font is this? Oh yeah, sorry about the crunch for my neck. That's a bad, I have some very bad programming habits, like while I'm working, I found out from doing these streams. The first one that some people have pointed out to me is that when I think really hard, and I'm not sure if you're able to see it, but now everyone's gonna notice it, like put my tongue out like this sometimes. If you look at some of the VODs from my earlier streams, you can see when I'm thinking really hard looking at the code, I'm like, and the other one is neck cracks, which like probably shouldn't be done live on a stream. Anyway though. It's a slight aside. It's a very personable stream today. Very yeah, very personable. So what we're going to be doing is the thrust acceleration is going to be the max of thrust acceleration. No, sorry, it's going to be the minimum because we want to clamp it. This thrust acceleration plus and then thrust max. There we go. Plus thrust power. And then this velocity. Sorry if that's not super readable for you guys. I think it's on the right side of the screen. Yeah, oh no, math. Basically what we're doing is we're going to accelerate the player up, but with like as the player presses the space bar to go vertically, it's going to be like slowly adding on to the vertical acceleration instead of like immediately going up with the same thrust. So you get like, you know, I want it to like feel smooth, if that makes sense. Why use this everywhere? Just for what's the word? Code readability. I'm very like militant about my usage of this when you're referencing fields on the current class, because otherwise I think it can get really ambiguous. And it happens also quite frequently that I have fields that have the same name in the class and the and my local function, and I never want to run into that issue of like you know, name shadowing and stuff like that. So this velocity gets added to the thrust acceleration gets added. There we go. And we're just going to see how this feels now. We're going to wait for the compiler. So do you hate M prefixes? Oh yeah, I really hate M prefixes. I think it is like illegible. And I think encoding the information like that, hey, that feels pretty good. I think encoding information like that is just like a little silly. It like in variable names. It reads like some old Windows code with the, what's it called? Like the reverse Polish notation or something like that. Yeah, I can't stand it. And when it's only me working on the code, I'm gonna just use this and stuff like that. I think it's like, yeah, Hungarian notation. Sorry, reverse Polish notation is something else, I think. That feels pretty good. So the other problem, you can see that there's like a slow, like the curve on like what's getting added to the velocity isn't like too bad. So the next thing I want to do is I want to make it that like, so it feels a little bit more like you're floating. Is that okay, we're gonna do a couple things. We're gonna make it so that his little legs don't run when he's floating around in the air, and I'm gonna make it so that what's it called? Like when the robot is in the air, I should actually stop referring to him as he. The robot is genderless. It's just a robot. They are just a robot. When the robot is in the air, I'm gonna make it so that there's like a lot more friction on XZ movement, like so that it's not just able to run around like this. I love your robot. I love it too. Yeah. So that's what we're gonna do. So handle vertical movement via thrust. Always make sure to document your code. Why are you not using Linux? Because macOS includes all of the Unix like tools that I need, and I think Windows laptop build quality is bad. But that's a little bit of a hot take that I'm not going to go into now. So yes, what was it we're going to do? The first thing. Okay, his little legs are moving. Their little legs are moving. The robot's little legs are moving right now. That's going to be fixed, and we need to make it so that he's the robot is not moving, like its movement gets slowed when it is in the air. So that is going to get handled up here in apply controls. So we have this, which converts the, so basically just to go through what this procedure actually does. Yeah, too hot of a take. Apple is a trap ecosystem. Yeah. We're not going to talk about my decision to choose Mac right now. Maybe at the end of the stream. So this apply controls gets called in the, I'll move it over here actually, so everyone can read it. This apply controls gets called in the tick function. So 120 times a second. And it basically, what it does, it looks through the controls, it looks up, right, down, left. It gets some 2D movement vectors. It adjusts them to the current camera rotation, of course, because it depends on like, I don't know when the last time I showed it was, but whenever it comes up from compiling. Yeah, there we go. The camera can rotate. So we need to be able to apply the, you know, if we're pressing up, the up direction changes as the camera rotates, right? And so, yeah. Oh, this was still in here in apply controls. I should actually move that. So just to keep my code organized, thrust, where was it? There. Handle vertical movement via thrust is getting moved into, sorry that the chat is covering the code. Is getting moved over here. And then this, what did I call it in here? Entity dot, there we go. Just because it's a status, what's it called? The static function. There we go. Handle vertical movement via thrust. So what we also need to do though is all entities keep track of, where is it? Keep track of, or like you can ask an entity whether or not it's grounded. So this will just do, it will basically check if like a point collides, I believe. It checks if a point collides with the world or like something. It will check if a point collides with a tile directly under the entity. You can see it takes the center point and then it like centers it on the bottom of the entity and then it moves like a little bit down. Yeah. So that's how we check the grounded entity, and we're going to be using this. Where was it? Here, to say that here, slow XZ movement and liquid. Well, what we're going to do right now is declare, what should it be called? Let's call it XZ modifier like this to scale XZ, and then we'll do, what is it? So if not entity got dot grounded, so if the entity isn't on the ground, we need to have the XZ modifier be like a little bit slower so the entity can't move as quickly. And that's, so we'll just multiply it by some low constant. And that didn't work. The player still moves very fast. So I wonder what's going on. Let's just do some really quick debugging. Because I think that the question of whether or not the player is grounded is getting messed up. Or maybe, was that even correct code? Okay, if the entity is not grounded, then the XZ modifier, oh, it's because we're not even using it. Oh, sorry, I bumped the mic there. Yeah, adding friction, exactly. Yeah, everyone is much better at looking at my own code than I am. Maybe it's because they're not trying to talk while they're doing it. But entity of velocity times equals XZ modifier.x, XZ modifier.z. Or actually, that is a smarter way to do it. There we go. There we go. now whenever it loads, you can see he moves normally. And now he moves. Okay, that's a little too slow probably, but you can see what we're going for. Right? Moves normally, moves slow. So okay. But that's maybe a little too much. So let's slow him down to like try 0.7 as the slowdown. Add code. Maybe that's still a little too much. Yeah, he's still moving a little too fast. We'll try 0.5, basically. There we go. And it looks a little silly because he's, yeah, wow, is that the running speed? Yeah, it looks a little silly because, you know, the little legs are still going, but it works. And I'm gonna need to figure out some solution for this, like, arbitrary level, like, vertical level cap, because right now I think it looks a little bit silly. Does Bgfx have good docs? You know, I don't want to like speak poorly about Bgfx, but the documentation is a little lacking. It has occurred a couple times where it's like the documentation for some feature that you find is like in a GitHub issue. Yeah, which can be a little irritating sometimes, but it's, you know, it's rather seldom that it happens. What does the J10 flag do on the make? That makes it use 10 cores to build. Anyway, though. Now the robot is hovering, which is what we came here for. But let's make it so that his little legs don't move anymore. So, what we're gonna do? Okay, yeah. Now we need to make it that his little legs don't move, even though it is very cute. Where is that controlled? So the player has a model player. You guys are looking through this code just as much as I am trying to figure out what I've done. So the player has a model player that's a model humanoid that contains this animation state that has swing for the legs. Oh, it also has some leg rotation stuff. So I think what we're gonna do is we're going to... How do we decide? Let's do it like this. So what we're gonna do is we're gonna make it so that when the player is hovering, like right now he's just moving like, I'll use my pen as an animation. Right now when the player, I'll hold it straight relative to the camera. Ooh, sorry, I bumped the mic again. Very unprofessional. When we are, right now the player is moving like this, right? But I want it to kind of move like this, right? So like when it's hovering this way, it should be leaning a little bit this way. When it's hovering this way, it should be leaning a little bit this way. So what we're gonna do is we're going to add to the animation state a keyframe list for, what do we call it? Like rotation body, or like, I kind of want to call it like swing body, because it's like how much the body is swinging relative to where it should be. Do you know what I mean? I can't really say do you know what I mean to like 400 people, but do you all know what I mean? Is what I'm asking. NVim setup, please. It's in the description. It's in the description. Lean. Yeah, lean. There we go. Or like, no, I think tilt is like literally a word. Tilt body. We'll just call it tilt. Swing is not the right word. It's not swinging, it's tilting. Tilt body. So we need to apply that. So this animation state struct is kept if we look at the player entity. We can see that it stores its animation state This model player animation state is a subclass of the humanoid animation state, specifically for players, right? And then these, what was I gonna say? Basically, this is stored on each individual entity because the model is not instance per entity. It only gets animation parameters as it's rendering, if that makes sense. So like if there were like 5 players on the screen, there would still only be one model instance. It's rendered with different animation parameters every time it gets rendered. But anyway, entity has an animation state which contains this body tilt, which we now need to apply to the humanoid, this model humanoid, if you guys can see it down here. So where we'll do that is, well, it's the whole body that needs to be rotated. So I think what we need to do is, let's start by tilting the whole player. Oh, sorry, I keep bumping the mic. Jeez, I need to be less like this with my hands. Let's start with the whole player. So if we look at like model base, this is the model matrix for that gets applied to the entire player. So what we'll start doing now is we need to, what axis are we rotating it on? The x-axis, I believe. Body roll. Yeah, I don't know what x-axis rotation is called in like flight notation, but it might be roll. Right, this is to explain why I'm picking the x-axis, because like if this is the player model, like if he's facing this way, you have the x-axis, the y-axis, and the z-axis this way, like into the player. So he needs to tilt around the x-axis. I'm really glad I have a face cam. I wouldn't be able to explain anything that I'm doing. I'm just using my hands all over the place. So anyway, yeah, it is probably body roll is the correct way to describe it. But anyway, so this gets that animation state struct. So what we'll do is just rotate the matrix and see what it does. Anim dot tilt body dot current. And we'll just rotate it by the current value of that body tilt. Around the x-axis, and that is not supported for some reason. Why is it complaining? Shouldn't current be oh yeah, we need a .git. Sorry, forgetting the code that I wrote on my forgetting my own code that I wrote. Anyway, so we're rotating by that body tilt, and now on the entity player, what we'll do is when the player is doing this thrust, we'll do entity.animationState.tiltBody. We need a new keyframe list, and I actually don't remember. It's been a while since I've looked at this code. So I'm going to look at, I think the player has like an animation. It's like a list of its animations somewhere, if I remember right. How does it apply animations? There's like some pluck animation, I think. Animate pluck, model humanoid. Okay, so this is what, yeah, I'm forgetting how my own code is written. This is very deeply unprofessional. But so basically that keyframe list that we're seeing is like a list of like, you know, it's a, let me show you what it is. So this is how all the animation is handled right now. It's like very, very simple. But it's just these keyframes, which are, you know, templated on some type of what value that they are. And they handle like linear interpolation between values at specific like times. So if you said like, right, like when the player is plucking, I'm gonna use my hands to animate again, right? His arms go like this. When the player like, what's the word? Like plucks a plant up. His arms, the robot's arms, their arms go like this. And that's done through this like pluck animation, because what it's saying is it's saying for each arm, it's creating a list of keyframes that are saying like 4 ticks from now, I want the arms to be down, and then 20 ticks from now, I want the arms to be rotated like this way, right? By negative math pi over 2 plus math pi over 4, right? And then it's saying, I believe this parameter is like what the current keyframe, oh, sorry, I keep bumping the mic, is what the current keyframe is, right? And it's constructed using an initializer list, but this is a really simple way to do animations. And so what we'll be doing is, well, first off, I'll just show how the like keyframe list works. So if we look at the entity player, we can, when we go down here, tilt body. So we need the entity.animationState.tiltBody.current. So we need to give it a list of keyframes. And so then let's say like in 10 ticks, we want it to be there, or like 4 ticks, let's have it be 2 ticks, let's have it be 0. And at 20 ticks, we'll have the rotation be negative math pi over 2. And we'll see, well, actually, this is going to need to be controlled a little more finely, but controls jump is pressed tick. So whenever the jump gets pressed, we are going to like tilt the body a little bit. It's just to, you know, just to see how everything works, basically. And we're going to wait for it to build. How long is a tick? Is it 1 tick per frame? It's 120 ticks per frame. So waiting for the build time. So the stream might actually die while I'm building. I should probably turn down the number of cores that it's using. Sorry about that. But now, okay, this is what he does when he flies now. So he's just chilling now. Every time he flies, he's just you know, leaning back and enjoying the flight. I think this is perfect. I think the stream is over. The animation works perfectly. Yeah, our boy is a little tilted, but this is animation. Thanks for coming, everyone. That'll be the entire stream. Features implemented. The game will be out on Steam tomorrow. Yeah. Yeah. Okay. Okay, this is pretty fun to play with. Yeah, 2-for-1 deal crawl animation. Yeah. He's also just he is going. Just release it as early access. Exactly. Yeah, this is what happens when you use your own engine, guys. Like this would be, if I was using Unity, this would have been, I would have just downloaded something from the asset store, you know, paid like $20 for it, and it would have worked. But this is what happens when we do everything ourselves, right? Okay. But anyway, this is a good demonstration of how the animation system works. So let's see what he's actually doing now. So he's getting animated. So negative tilting, that makes sense, right? His x-axis is getting animated to 0, and then it's getting animated to like this. So I think what we need is when he's thrusting. Oh, thank you for the donation in my native currency as well. I will ship it just for you, Alex. We need to tilt him actually around his center point. So let's fix it a little bit. Because right now, when the animation is being applied to the base model, you can see that we're not doing any like what we need to do is right now the origin is right here. So where it's being rotated around is right here. So we need to translate down, then rotate, then translate up again, if that makes sense. So we need to get like a tilt offset, which will be like this offset, or sorry, not that offset, this offset for the player. So let's call it tilt offset And that's going to be purely in the y direction. So that's going to be size body.y divided by... It's good that this is happening in the center offset. It needs to be happening there anyway. Size body.y divided by 2, 0.0f, right? And that's the tilt offset. So that will move our player, you know, down into the middle. So then we'll do the same thing right here, where you can see that this call to rotate is wrapped within these two translations. And now it should look a little more reasonable. It should be rotating around, like around the middle. Okay, he's not... Oh, it's math like pi over 2, so we won't be able to see it unless we... There it was. Okay, we'll do a little bit less of a rotation. We're using gruvbox theme. Yes. Oh, you can't really see it, but yes, my editor is my NeoVim. The theme is gruvbox. This is C++ Unity bad, in case anyone was wondering. There you go. now this is working. Now we're getting somewhere, right? He's walking a little bit like this, you know, just hanging out. But this is definitely getting somewhere. He's now being rotated around the middle, which is appropriate. This is fantastic. And his head rotation is still working, I think. Yeah, he's just going around in the air, spinning around. Yeah, Robo has jetpack. Sigma pose, true. That's the robot is giving Sigma. Well, he's not what's the word? He's genderless, so he's just giving Sigma robot energy. And Real Engine is a bit overkill. It is adorable. Okay, so we'll have him lean slightly forward now. He is vibing. Yeah, true. Oh, I need to keep... For some reason, it doesn't open over here. There we go. You know, this is a slightly different pose, but this is also correct. So now he's leaning into it when he's going up. So that's perfect. So what we need to do now is we need to like calculate it as a function of like how much the robot is moving in each direction. Yeah, now he looks a little sad. We need to like calculate as a function of how much the robot is moving in that direction. So the way we do that, or actually, should it be tilted from the top? Because right now that offset is sending it here. So it's tilting like this, but I kind of feel like because the thrust is coming from the bottom, it needs to be like tilting like this. So I'm actually going to change that again, that offset that we were using. The tilt offset is just going to be the whole body size. So it's going to be getting tilted from the top. Whenever, there we go. There we go. The calmest chat I've ever seen with 359 people. Yeah, everyone is well behaved. I really appreciate it. Thank you. Feel free to ask questions and stuff like that, but you know, maintain the well-behavedness. It's going very well. Anyway, so now he's being rotated to the top, basically. Wouldn't pi over 6 be more natural? What are you talking about? This looks very natural. I don't know what part of this looks unnatural to you. Yeah. Why did you make this game dev in C but not in Java? Because Java isn't portable as much as I love Java, which is also a very hot take. I do really love Java. So anyway, what we need to do is entity player. Yeah, let's try and make it look a little bit more natural. Let's try pi 8. Someone suggested pi 6. Let's try pi 8 and see how much that uses. Java icky. I don't want to hear... yeah, Pi 8 is maybe even a little too much in terms of the rotation. He does look very cute, but okay, maybe we'll keep it as Pi 8, and or like Pi 8 will be the max for like this speed, but then he'll be like, you know, he'll go up to Pi 8 as he's moving faster. So what we need to do is, oh, I think I might need to actually, how do I do that? We needed to tilt like as it's moving. So what do? We need to say if the player is thrusting, and this animation totally should not be controlled here. So let's do it like this. Entity player tick. Okay. This will probably be to move elsewhere, and then I can't spell elsewhere, and then we'll be balancing jetpack, initialize power that you need to regenerate. Yeah, exactly. Yeah, there will be added balance. Right now we're just like testing the movement mechanics and stuff like that, right? So move elsewhere, and then this will be handle thrust animation. So what we'll do is we'll say if the player the thrust acceleration is greater than, you know, some like epsilon value, some like very small value, then we will tilt the animation slightly. And we'll see how that looks. I think this will actually be like quite borked because it's always yeah, nothing's happening because it's constantly getting reset to 0 from the animation. So I think we actually need to add something that will like, will you leave the record of the stream, or like the recording? Yes, the stream will be available once I'm all done, but that doesn't mean leave now because then you can't chat, but the stream will still be available on my YouTube channel. But you can see right now what's happening is where whenever the thrust acceleration, so whenever the player is, oh wait, no, that works, never mind. With the thrust acceleration, whenever the player is in the air, then it's getting, the body is getting tilted, but because it's constantly resetting down to 0, nothing's happening. So what we need to do is tilt body 2 ticks. We need to add a new we need to add something new to our keyframe lists. I wasn't planning on having the stream deal so much with animation, but if you remember from a little bit ago, the keyframe list is basically like a list of keyframes for each like animation component to follow or something like that, like the rotation of the arms and right now the tilt of the body. So what I'm gonna do is we need to like add or like make the body tilt go a certain direction as the player moves in that direction. Is that a low pass filtered version of the velocity? Yeah, that could actually work. 3 months in the video, you said the code, the video had the code of more than 20,000 lines of code. Yeah, it's gotten bigger. I wonder if animating on the velocity would just work. Maybe not. Maybe I'll try that at a later time. Anyway, we need to have the body tilt working basically. So right now the body tilt is controlled by a keyframe list. So what we need to do is we need to like append onto the keyframe list. So what if we added the tilt body? Maybe it doesn't need to be a list of keyframes. Maybe what we need to do is, oh, my emoji keyboard came up there. Start is global time ticks. How do we manage that? Does anyone have any good ideas on how you manage animation like that? I think we need to like, okay, let me try and make it simpler. Model humanoid. Let's just try this. Let's keyframe it later. But so the body tilt is going to be managed like that. Model humanoid.cpp. Okay, so we'll make the body tilt, and we'll just handle animation later, because I'm not sure how we need to manage like the keyframing of the animation. Are you making your own game engine? This is the game engine. Whenever it comes up from the build. Yeah, okay, so this works. So now what we need is we need like a tilt proportional to the sideways velocity, so like the XZ velocity. So the way that we're going to do that is we're going to do this velocity.xz. We'll multiply the length of the xz vector times like some sort of value. So I think what we're actually going to do is we're going to bring the code out. Hopefully still in a way that everyone can see it. Still covering most of the screen. I'll bring it over here so that the chat is still legible. There we go. Now everything is like properly aligned. But the stream looks a little more scuffed, so excuse me for that. But what we'll do is handle the thrust animation. So we need to find out while the player is moving, like how much, what the length of the XZ velocity at the maximum velocity is, because that's how we're going to scale how much the player tilts, right, as it's moving. So I'm going to do a classic programmer tick and just print it out so we can figure out what our like maximum value is rather than literally computing it, because that would take a few seconds and I'm gonna save some time. For some reason it's still not opening on the right monitor. You can see down there the maximum velocity is 0.012 ish. So what we'll do then is we will have the tilt body be the length divided by 0.012 value, right? Was it? Yeah, 0.012. And then we'll have that be multiplied by that, right? That like scaling factor. And I promise these won't be magical constants later. But now we'll multiply that like math pi over 8 by that original tilt like this by like how much the velocity is. So the more the velocity is, the more of that math pi over 8 we'll get. I still don't know why it's opening on the wrong monitor. Oh, now it's opening on the right monitor. Okay. Now he just looks like he's running a lot in that direction. Which isn't exactly correct. Yeah, I don't know about this. He looks like he's like very interested in going the direction that he's going. He looks like he's sniffing a little bit, like on the ground, just like. Yeah, he does look. No, he is doing a Naruto run actually, and flying as well. Okay. Thrust acceleration. Oh, the problem is because the thrust acceleration is never getting like. So the thrust acceleration is always staying at the maximum value, whereas. Where did I lost my code? Where was the tick function? Oh yeah. So this thrust acceleration is always staying at 0, so he's always staying like up above. Maybe make it quadratic instead of linear. Yeah, he really loves the dirt. So we need to also in the entity player, basically like in Or, yeah, we'll do it like this. Apply some drag to the thrust. We'll apply like 0.985 or something like that. And so we'll try, where is it? We'll apply thrust drag, thrust acceleration gets multiplied by, and this is just to thrust drag, and then it will also get zeroed out to make sure that we don't get like incredibly small values in our vector. All right, if the thrust acceleration is very low, then it just gets, oh man, I really cannot type today. There we go. Then it just gets zeroed. Right, handle thrust animation, stuff like that. And now he should only look like he shouldn't sniff the ground anymore. He should only sniff the air, or only Naruto run when he's in the air. Are you get good at programming? You code a lot. Okay, that's not exactly correct. He's still sniffing a little bit when he's in the air. Why is that happening? Is it because the thrust acceleration is greater than 0 still? Why is the thrust drag not making it much smaller? I don't know exactly why that's happening. Because, right, multiplying the thrust acceleration by the thrust drag should make it smaller. Okay, now he can't thrust at all, which is bad. What if we try 0.65? This would be really bad, much better if I actually had a, you know, I knew what the math, the correct math would be while I was doing this. This isn't working. Why is it not working? Why is he still just looking like slightly down? Oh, it's because the animation isn't getting set. So the code is actually working. My mistake. So we need the body tilt gets set to 0.0, right? So it gets set completely back to normal when the player has no thrust acceleration. So that works. It's not pretty, but it works. But what I don't understand is why it looks like he's tilting up from the bottom. It's definitely not pretty, but it's slowly but surely getting better. Let's try interpolate. Yeah, that's what the keyframe, the animation keyframes are going to be for. But what I don't understand, oh yeah, he is just kind of going down directly into it. Let's do 0.012 math pi 8. Yeah, I guess that is the right way to do it for like the flight velocity. And then I'll put in to do don't use magic constant for maximum flight velocity. Actually calculate it. Right, that's a problem for later me or later us. It would be better to do thrust times drag over thrust. Oh, so the drag gets like scaled with the thrust. Right, thrust times drag over thrust. No, wouldn't that just like bottom? I'll just keep it like this for the drag right now because it's also like it's being applied to some sort of acceleration, basically. So yeah, for everyone discussing file extensions in the comments, I use CPP and HPP just to be clear that it's C++. I don't think using H for C++ headers makes a lot of sense, because I would think that they could then be included into C files, but they can't. So anyway, and then for C, I use C and H, right? Anyway, though, so now we need to animate. So I think the way to do this is to, because right now on our model humanoid animation state, we have this F32 tilt body, right? So we need to change this to a keyframe list of like a keyframe, so that like the player is constantly getting like the tilt is constantly getting slightly adjusted to the current direction from the keyframe list. But the problem is that keyframe lists don't support that right now. So we might actually need to add that. What C++ standard version are you using? I'm using C++ 20. But anyway, anim_tilt_body.get, right? Because now we're using the keyframe list for animation. And then now the tilt body needs to actually be a keyframe list. So what we'll do is, and then the previous, this animation state tilt body. Right, so we're gonna add some slight animations to this. 2 ticks, we want it to be back to normal, and then this animation state tilt body dot current. No viable overloaded equal. That's not so good, but I think things are getting constructed appropriately. We'll see how things are looking in a second. There we go. Here is the... So what we're doing right now is we're keyframing the animation. So we'll say in 2 ticks, we want it to be like that. And this might actually work. Animation state tilt body. Why can that not be adjusted? Why is there no... Because tilt body is a keyframe list. I don't know why this isn't getting properly initialized. Keyframe list F32. No constructor matching for initialization. What is going on? Is this not the proper constructor? Why is this not? Is that why? C++. This is simply not fun. Oh, it's because this needs to be an initializer list. Sorry if someone caught that. I'm not on the top of my game today. There we go. And so there and there. Right. Now it's an initializer list, and now C++ won't complain. There we go. Don't you think you need to abstract things a little bit more? I don't really see a reason to. Abstract away. Yeah, like, I mean, I'm also... Things usually the way things go with these streams is that I implement stuff on stream and then I abstract it away later. Well, that's definitely like some animation. I think 2 ticks is probably like not enough time. So let's give it more time. And see how that looks. This will always be kind of like chasing the current value. I think we'll no, that's not working either. What if we say in 100 ticks it needs to reach each animation state? And No, it's still not animating properly. I wonder why that is. He's still just kind of like dipping. Yeah. So we use 100 on the same, but it's because the keyframe lists don't like support this operation basically. Looks like he's not respecting delta time. Yeah. Oh, sorry, I did say 120 ticks per frame before. It's 120 ticks per second. It's the tick frame. That was really unclear before. The tick, there's no what's the word, locking between ticks and frames. Like there can be like 3,000 frames, which is 120 ticks per second always. Don't you need to animate it greater than 120 ticks? Yeah, sorry, it's 120 ticks per second. So 100 ticks will be like the better part of a second, right? But so the problem here is that our keyframe lists basically like don't support the operation of very well at least of being like modified. So what I'm trying to do is trying to make it so that like it's always chasing like the current velocity value that it's supposed to have, but that just doesn't seem to be working. And I don't really understand why. It's probably also because because it's getting the current keyframe off of the old animation. But it's not actually interpolating between them is the thing that is unexpected. Do you need an append method? Yeah, that's what I'm thinking. Is an append method on the keyframe list that would like, but then keyframe lists suddenly become this like thing that need to manage their internal state and like get rid of old keyframes basically. That works actually. The animation when he's like tilting down to go a direction is working. Which is proper. Right. So that actually that works fine. It's actually just when he starts moving. Oh, okay. I think I know what the problem is. So the problem is as soon as this thrust acceleration is going up, it's automatically getting booted into the like maximum tilt. But because what's going on, it's automatically getting booted in the maximum tilt, and then okay, wait, keyframe lists don't need append methods. I need to manage my keyframes better. That's what's happening. Okay, so here's what's happening. Or like I think what's happening. So as soon as the thrust acceleration is going over 0, right? So right now, oh sorry about the mic again. Right now the player is moving like this. So this like this velocity vector is getting higher than this. The length of the velocity vector is getting higher than this 0.012 value. Yeah, welcome to debugging with JDH. It's getting higher than this 0.012 value. So the initial keyframe, as soon as the player goes up in the air with the thrust acceleration, is being it's telling it to rotate like this, right? Like very violently out this way. And then this current thing, which is like, then the next keyframe, once this value goes back to a normal value, is getting like, it's interpolating from this value up to this value instead of from this value rather to this value. Does that make sense? Does everyone understand that? Basically, it's because the acceleration is really, the velocity is really high in the start, it's interpolating from here to here rather than here to here. So is that pen a Pilot G2? It is. I'm not a big pen guy, but this is my, if I can get it in focus, that's my Pilot G2. Now I'm probably going to be slightly out of focus. Yes, you should interpolate to the target, not accelerate and accidentally overshoot. What watch do you wear? I actually forget what the name is off the top of my head. I think it's called Larsen Wax, and it's like a Danish watch. It's also completely busted right now. The battery is out. So this is not the current time. So, what are we going to do? We are going to fix that. And the way we're going to fix it is by, instead of using the current, because if you look at the keyframe, what it's doing is when you were using this current method to do the last, oh, am I blurry now? Wait, sorry, I'm gonna, sorry, stream internals. Is that, am I in focus now? Yes. There we go. My camera needs glasses. Your English is so non-Danish. I'm from the US, but I moved to Denmark and now I speak mostly Danish if I'm forgetting words. There we go. Now we're back and now I'm not blurry. Where was I? What we're doing is this current value that's getting sent into the keyframe list is like, right, so we give a list of keyframes that's specifying an animation, and it's saying like this parameter is the last, you can see it right here, it's the last keyframe that the new keyframe list needs to start interpolating from. But the issue is, when we're giving these new keyframe lists, if the last keyframe looked like this instead of like this, right, we need to be going like that instead of like that, then we're interpolating from here. So what we need to be able to do is construct a keyframe of the current animation state. That makes sense? So we need to be able to ask a keyframe list, not like, what keyframe are you going for? Or like, we need to be able to ask it, if you were a keyframe, what would you be? So that's what we're going to do. So what we'll do is, we'll do as keyframe, which will, what are the, so we have the keyframe list. Where's the keyframe list? Keyframes is a vector of keyframes. So what we need to do is we need to do, we need the keyframe of like, what do we construct it as? We need the number of ticks targeted is, oh geez, how do we do this? What are the parameters? It's the tick at which animate is the value, the target, and the keyframe previous to this frame. So I don't think we'll fill in the previous field. So we just need the tick and the target. So the tick is 0, I think. Wait, does this? Yeah, I think that stores literal ticks. Sorry. Okay. As keyframe, U64 time is global dot time ticks. So we'll get the current time in this get. Expected, what am I? Oh, missing a comma. You know, you think I'd be better at stuff like that by now. Is everyone understanding in the chat? I hope I'm doing an adequate job of explaining everything for everyone. but this is so we need to convert a keyframe list into its current value as a keyframe. And so what we do then is we do as keyframe as the last animation state that we're interpolating from, which I think should work. This current git. Oh, I think this might crash actually, but we're gonna try. I'm pretty sure this is gonna crash because initially you don't have like a current keyframe, and it's going to start by asking for the current keyframe, I think. Oh, that works. You can see it's animating really slowly, and then it's really slowly over 200 ticks, moving him back up. See? That totally worked. What does math length do? That is vector length. Really slowly getting tilted back up. So that's perfect. So now we just need to make it a little not as long, like the amount of time that it's taking to do each of those animation steps. 15 ticks is maybe still too long. But now he's like appropriately getting rotated in that direction. There we go. I think the rotation is still maybe a little bit much, so we'll do like pi over 8 plus... What do we need? We want like math pi 10 to make the animation like not as or like the tilt not as much. But then I think that should work. And now he will be... Oh, sorry. I hope you guys could all stream that. Oh, thank you for the donation. Sorry for being annoying, but can you recommend any resources to learn Bgfx that isn't just reading the examples? That is unfortunate, and I wish I could recommend something good because of the donation. That is unfortunately the only thing that I can recommend is reading examples and just looking at the docs. I wish Bgfx had like some tutorials out there. I could maybe consider doing some at some point, actually. Maybe doing like a Bgfx introduction stream. But like, you just have to read the examples. They're pretty decent though. Like they can be a little tough to understand, but I would just recommend like read through the docs, and then like a lot of Bgfx stuff is like, what's the word? It's very like generic to graphics code. So that is the best that I can recommend. Okay, now the tilt is a little less, not as bad. So now he is actually like hovering a little bit. There we go. So this is our hover function. So now what he's gonna look like when he digs a hole and he hovers out of it. It definitely needs some polish, but it's absolutely there. And he's definitely just leaning properly in the direction that he's trying to hover in. So the next thing we need to do is we need to make sure that the little... Oh yeah, the head shouldn't tilt. Yes, yeah. That's the next thing that we need to do actually. The head should not be tilted. The body needs to be tilted, which will be interesting. So, okay, now we're tilting. So... we make the animation slower since you cover a smaller angle? Maybe. I'll be tweaking these values later on, I think. But so what we're going to do is we're going to go to the model humanoid, and we are going to add model base, model head. We need to add a new modeling function. Sorry, model matrix function, which will be model body, so that the body model can be separated from the head model. And so what we'll do is we will just copy this model body, because what we want now is the head stays parallel to the ground as it's moving, but like the body gets tilted out a little bit like this. There you go. So this tilt offset we'll get down here. Oh, this size body offset was actually completely incorrect. So we want his size body and the size of the leg. Right, we want the size of the body and the size of the leg. So size body plus size leg dot y. That's also probably why it looked a little bad. And then what we want is const mat 4 and base. There we go. The head should stay parallel, but should look down to the landing spot when it reaches the top of the jump arc. Oh, thank you for the donation. I don't know what your currency is, but what camera do you use? What is my haircut called? My haircut is called the one that I gift myself when I cut my own hair. So I just use some scissors on it. I have no clue what it's called. If you want to ask your barber, you can show him the stream. What camera do you use? It's a Canon 40D. It's like a really old one that I've just hacked together to set up. And thank you very much for the donation. Oh, I do have 2 model bodies. Model, what should this be called? Model not head? What's a good name for everything that's like that isn't body, but it's everything but the head? Model lower, I'll call it. So let's do this. New Israeli Shekel, thank you very much for the donations. Model X, model headless, model limbs. No, it's including body, model torso. Model trunk, trunk works. I'm gonna go with lower right now though. So anyway, what we want is this. So we want auto M is base, and then the const mat 4 and base return M. So I think that's what we want to do now, and that will properly, I'm just talking very slowly because I'm trying to figure out what I am doing. So now what we want, okay, so now we have this model lower, so we want where does model base get called? Yeah, okay, so we have the base model now. And then we have the, let's rename this. Oh, we can't rename it. We shouldn't rename it the same as the method. Lower model. So this model lower, entity, params, anim, and base model. Right, and then now instead for head, we'll still use the base model, but all of these other ones will use the lower model, so they will get rotated now. Does that make sense? And I think this should work. I think this is gonna work. I think I've done everything correctly. He's gonna get slightly offset. Oh, unless my matrix math is very wrong, which it absolutely could be. There we go. You know, this totally works. This is very cute now. He looks like very interested in the direction that he's going. Like he's doing this when he's flying, but now he looks like he's like swimming a little bit in the air. He looks like he's doing this. He looks like he's trying to run a little bit. I think with some particle effects, this will totally work. And maybe like the blinker will be going a little bit different. You'll still have the head propeller. The head propeller will absolutely be added. I think that will be be a very nice addition. There we go. But now he can fly up. Just like that. And now it's I think the tilt animation should actually be even slower. Just to do some tweaks. Thank you to whoever suggested that earlier. This will probably be like parameterized somewhere else later, like how many ticks this needs to take. Magnet getting in my spam. Yeah, thank you YouTube for filtering. Very low tech stream here. Anyway, there we go. Now our boy is flying in the air properly. He looks like he's being like really attracted to whatever direction he's trying to go. View on microcontroller, please stop spamming. Thank you. I'll ask you nicely and then you're gonna get booted. I think that is good though. Okay, so now what we need to do, now we need to make sure that the legs aren't kicking in the air so he doesn't look like he's swimming anymore. So how do we do that? We need to check that the rotation leg swing. So what we'll do is as he starts flying, how do we do that? As he starts flying, we override the animation for the, where is it here? So if he is, if it's being thrust in a specific direction, then we do the same thing. We do this animation state dot rot legs. So for each side, for all sides, this is just a for loop over right and left. We change the keyframe list here. So this will be 25 and then 0.0f. Right, so we change the leg rotation to go back to 0. Rot legs. Oh, we need to do, where did I go? Go back. Side as keyframe. I think this should work. So now the legs are going to be locked in position as he's running, as he's not running, as he's flying. There we go. It looks a little silly. The arms are still going. I don't know if I'm going to keep that or not. But that's working. And then let's just add some right now. If the player is thrusting, we're just gonna add some smoke particles out of his feet. Flapping his arms like wings, exactly. Exactly. So what we'll do is entity, I think I have a smoke particle. Let's see. Yeah, I have smoke particles. And so there we go. Thrust acceleration. No, we need the next one. There we go. And this code will be getting a little bit messy, but you know, that's fine. I'll clean everything up after the stream because the uninteresting part is cleaning up all of the code after you've written it. So if he's accelerating, then we'll do entity smoke particle spawn, or there should be entity particle spawn entity smoke particle. And then what are the parameters on that? Spawning entity smoke particles. How do we do that? So we have this level, right? Which is, I believe, a reference to the current level. Then we have, what do we need to do is we need to make them spawn out of the feet. So we'll do get the center, and we will get the center position of the entity, then we move it down to the bottom using this XYZ to XNZ, which takes a 3D vector and replaces the Y value with something else. It's just like a convenience method I made. And then we need, yeah, let's spawn 1 to 3 smoke particles, And then the color will be let's look at the, I think I still have a, do I not have a torch item somewhere? Tile torch. I think I still do. Emit particles. What is the smoke color? Oh, it's just like some gray. Okay. Can we add a span? Wait. Entity, smoke, particle. Entity, particle. Sorry, I'm getting lost in my own headers. We're trying to spawn some particles out of his feet, basically. Is what we're trying to do now, but I'm getting lost in all of my various constructors. So what we want is spawn. Can we spawn with one color? No, we can't. So I'll do this. I'm going to add a new spawn function onto this. So const v and color. And then what we'll do is we'll do this. We will spawn entity particle. Basically, we need to override this spawn method so that we can spawn using a single color rather than a list of colors. It's very much like, this is not the interesting part of coding this. So my apologies, but level, pause, min, max. I think that should work. Const v. I think that's the proper way to instantiate that span as well. But we shall see when I try this. No matching function called to spawn. Okay, everyone get ready for reading C++ compiler errors with JDH. This is, you know, I hope this is all what you came here for. Oh, no viable conversion. Oh, I think that should actually be fine then. Hey, it works. Okay, at least Ceiling D doesn't complain. Here we go. Must be at least 100 words per minute. Yes. There we go. So now, okay. See, it kind of just looks like he's smoking out of his butt, but there are smoke particles coming out of his feet now. Maybe they should get like a slight velocity in the opposite direction of his like a slight boost in the opposite direction of his the robot's velocity to make sure that they look like they're coming out of his feet. Yeah, typing speed doesn't really matter when writing code. That is absolutely true. It's mostly just thought. Make the smoke white. Yeah, it probably should be. I'll make it like a very light gray. It's spawning a lot of smoke right now, but then we'll do. Oh, this is gonna kind of be a pain. Okay. I know I've welcomed you all to the stream many times, but welcome to Slightly Refactoring with JDH. We need to have references to all of the particle entities that we just spawned. Which, oh, actually, okay, we won't do that. We won't do that. I'll do, let's see if we can, because I really don't want to spend time refactoring the code right now. Let's have this return an entity ref. No, wait, we can't have that one do it. Level spawn. Okay, real quick refactor. I hope everyone will excuse this. We need references to all of the entities that we're spawning into the world so that we can change their velocity slightly so that they're going out of the robot's boots, or like his feet, if that makes sense. So, wait, no, never mind. Okay, I'll complete the refactoring later. We'll just have it return a reference in the spawn method, and then we'll have it return that, right? Because that also returns a reference. IEntityRefT. Don't worry about this. We'll have it spawn a single smoke particle, and then we'll do particle, this, particle. Okay, the velocity gets added with the, right now let's just do the opposite of this velocity. We need to add it only on the X and Z axis. Actually, let's just add negative this velocity right now and see how that looks. So if that makes sense, we're spawning in the particle, we're getting a reference to it, and then we're shooting it out like backwards. It's a little, what's the word? Like violently spewing. Probably because it's spewing one every single tick. But it's, it works. This is my example. Someone was talking earlier about, in the chat, about ECS being slow and stuff like that. Look at all these particles and no slowdowns. Okay, slight slowdowns on the tick time, but you know, you can see what I mean. This is a lot of particles and each one is an individual entity. Okay, we probably don't want them moving as fast though. So we'll do that. Give the particles velocity going away from the bot. That's what I'm trying to do, but they're not going enough in that direction. I think it's because their drag is much harder. So let's just like boost this up. This velocity times 5 will probably shoot them out back that way. And then we'll see how that looks. Okay, that's very like violently spewing them now. He's polluting everywhere. Those are probably just because there's so many of them. So let's do like just this rand chance. So let's have it spawn like 30% of the time. We'll have it spawn this particle. Ah, magnet is getting in my way still. There we go. Hopefully he's not emitting carbon. Yeah, maybe he should have the head propeller because it's more green. Oh, now it's like no particles are getting emitted. Oh, of course. There we go. Smoke looks like he's going up, making move towards the ground. Yeah. Okay, that's still like unreasonably violent particle spewing, but it's a little bit more in that direction. I think I will eventually add the head propeller so that he's moving like what's the word? So that he's more green. And the smoke particles will just be a test. But anyway, that is I would say like a slight mission success in terms of adding the hovering to the feet in terms of this feature. Their lifespan is too much. Yeah, I think so as well, actually. The particles should have more velocity downward. Yeah, I don't know. I'm probably going to remove the smoke particles, I'm thinking, in the end, but... And then I think he needs to be able to move maybe like... I think the vertical acceleration needs to be a little slower, and he needs to be moving a little slower when he's like actually in the air. I want it to feel a little bit more like this way. Maybe that's the wrong idea. Maybe actually needs to be moving a little bit faster. Anyway, this will be, he could be burning hydrogen to create water vapor. He could be. I think I'm just gonna have him be like, he'll get the propeller though. I think that'll be a good in-lore explanation for what he's up to, where he can float up. That's a comfortable movement speed actually. And then with the little propeller as like a little movement indicator, and then I think I will make him blink like a different color. That could be something that we could do actually. Because right now, the blinker is just being controlled by like this. Where is it? Here, the blinker is just being like arbitrarily added as a light source. So what we can do is, this will be formalized later, but if the thrust acceleration is greater, so if he's flying, I want him to get like a little warning light on. So global dot time ticks divided by, let's make it like a little faster. So divided by 40, let's have it go like double time. Divided by 40 mod 2 equals 0. Then, and this will be formalized again, so I'm not gonna copy all of this code. Let's just do, yeah, this will be formalized later. Don't pay attention to the fact that I'm copying so much code and it's bad. ARGB, let's try giving it a lot of R and a lot of G, and then just see how that looks. So now when he's flying, he should blink really quickly yellow, or like reasonably quickly. That still looks pretty green. Maybe he should blink red, or like faster. So let's try 25, 3F, 2F, 1F. Then that should be good. The propeller on his head should smoke? Yeah, maybe. Okay, now he looks like he's in like a real warning situation with the blinker. Okay, that's kind of cute. I think the red light needs to be a little bit more intense actually, to blink a little bit more. Random blinking. Yeah, blue light could also work. This is a little bit too like warning. Like I think I want him to blink like this when he's in like low power mode. Okay, let's try a blue light. 0 to because like he's still chilling when he's flying up. I think yellow would kind of work. Limit to flying distance, color could change according to range. Yeah, that's a good idea. Okay, that looks a little silly because the blue is like, oh, thank you for the donation. Windows versus Linux versus Mac OS. I appreciate the donation. I don't appreciate the flame war initiation in my chat. I think it's okay whatever you want to use. I'm gonna, you know, douse the flame war before it starts. You can see I don't think the blue light works too well on his head actually. Okay, we're gonna try a quick yellow color. I think we'll just make it very yellow and see how that looks. Blue looks cute. I don't know. The yellow just doesn't look very yellow to me. But I'm also very red-green colorblind, so that could be it. It does look very intense though. It looks like he gets hair every other frame. Yeah. I don't know. It looks a little bit like a warning light. I'm thinking like the backup lights on like a truck, as like when it goes like beep 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 as it's like backing up. How does my code compile so fast? My code compiles really slowly. But I think that works pretty well actually. Flip between red and green. Do aircraft flip between red and green? Oh, you know what I'm gonna do actually? I'm going to, I don't have time for this right now, but I will be adding like, maybe I'll add like a light on the end of the propeller, like an aircraft. You know, like something that he's like on the end of the wing, so they can like rotate around a little bit. I think it'd be pretty cute. And then you can also have like a little like, I can't make propeller sound effects with my mouth, but like a... Thank you very much for the donation, Spawn. But I think I'll do it like, you know, like a sort of sound effect or something like that, for his little propeller. I think that would add a lot of personality to the Robotanist. This is will there be a video summarizing this later? I'll probably summarize the stream in my next video. But blinking red light, yeah. Something along the lines of blinking lights, basically. I think right now I'll just keep it as the yellow, though. Yeah, that looks pretty good. But I think, though, this was planned to be a little bit of a shorter stream, but I think that's about where we'll probably be wrapping up for today. I kind of want to like answer some questions because you've all been well behaved in the chat today. So I would like to answer some questions, I think. Next to the blinking robot. As long as the questions, a little piece of advice to chat. If you ask a question that's too personal, I'm probably not going to answer it because I do like being an anonymous internet content creator. So anyway, though, if anyone has any questions that aren't, I can't really. Let me see. Oh, do I still have the? Where is it? Copy text, paste. There we go. That aren't here, 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 or here. I will be happy to answer them. There should be a little dust up when he lands. Okay, I will write that down. Dust when he lands back down. Head propeller, dust when landing. That's a very good idea. Thank you. Okay, I'll turn this off. Are you using OpenGL? Hope this isn't too personal, but what's your social security number? 1 2 3 4 5 6 7 8 9 10. 10 is the last digit. That's my SSN. If you want it, feel free to open credit cards in my name. It's JDH is my whole name. Thank you for the donation, Banana Man. Are you using OpenGL? This is using Bgfx, and then it's running on Vulkan as the backend. Are you trying to sell the game, or is it just a passion project? I'll move the chat up to a place where it looks like I'm looking into the camera a little bit more. I am right now. I'm probably looking to sell the game at some point, but that's like far in the future. You know, it's not really consideration right now exactly what that would look like. What's it? Yeah. Thank you for the donation. Here's here are all the answers to your questions. Small screen shake when jumping. That could be interesting, actually. I'll also write that down on my list of good ideas. Screen shake, jumping. Screen shakes are very indie, I feel like. I think like the effect that everyone adds is screen shakes to everything. Have you tried Rust? Yeah, I answer this in almost every stream, but I have tried Rust a little bit. I find that it gives a lot of friction when I'm trying to do what I want to. I would be interested in trying it more, but like the other thing that I've read is that Rust has like equally, if not equally slow, if not worse compile times than C++ in a lot of cases. And my primary motivation, honestly, for moving to another language would be if it had better compile times than C++. Because like that slowdown on the development cycle, just like, I don't know, it really, the only phrase I can think of is cramps my style. Is your NVim config online? Yeah, it's in the description. How do you get your hair to be that luxurious and magnificent? I use a little bit of sea salt spray and some like argan oil in it after I wash it. Treat it well, don't wash it too often. And then I cut it myself, so I don't really have any advice in that direction. Do you have a CS degree? Yeah, I do. Just regular computer science degree. What's your current compile time? From like a cold compile? I don't want to think about it. I think it's like 45 seconds to a minute, if not more. If you're building libraries, it's going to take like 5 minutes. Why did you decide to stop using C? I kind of want to type safe generics. But with some of the stuff that's being added to C23, I think, like, I don't know, sometimes I've kind of regretted picking C++ over C for this. I think in a lot of cases it's added a lot more complexity than it's worth. What debugger are you using? I use LLDB when I debug, but I also have a copy of CLion or Client or whatever it's called. That I use for like visual debugging. But I think I also have an integrated visual debugger in Vim, but I just haven't tried it yet. It's built on top of LLDB. Do you recommend Bgfx over anything similar? Is there another reason to use it? My profession is programming. For Bgfx, I would recommend Bgfx if you're trying to build like cross-platform games and stuff like that, and you're not using an engine or some other rendering library. I could also recommend Raylib is pretty fantastic if you're looking for something a little more high level. Bgfx is really low level, or like relatively low level. You know, it's just one layer of abstraction over graphics APIs. So like I think it's good if you're looking to move from like a lateral move from OpenGL in terms of complexity. But if you're, for most people, I would recommend using like Raylib or something like that. Have you used Arch Linux? It's been like a decade, but I liked Arch Linux when I used it. Do you regularly check for memory leaks? I do. I can show you guys here. Oh, yeah, just in case anyone was wondering. Let me close the game down. This is when my build times get really bad. I have in my make file these that I can just slap some flags on everything. I run a clean build, and then I use the address sanitizer and stuff like that to check for memory leaks. But you know, they aren't really frequent because most stuff in the game gets allocated onto these like bump allocators that get cleared every frame. So it's like there it's impossible to have a memory leak because they get cleared every frame. They're just like that sort of automatic cleanup on them, basically. Oh, that's me pulling up the chat. I should have oh, that was too much. That was me briefly accidentally showing my primary screen. Which one do I want? Camera only. Yeah, you can tell that I'm an inexperienced streamer. Yeah, forehead cam. What are you using to handle input and audio? GLFW, I think. Yeah, I'm using GLFW. Is your NeoVim config public? Yeah, it's linked in the description. Heard of Zig as a C alternative. Yeah, Zig is really interesting. I've done some smaller projects in it, but I haven't done anything larger in it. Once I'm done with this project, or whenever I'm looking for a new language for a different project, I want to investigate Zig. Absolutely, I think it's really it looks really promising, at least. Does your Robotanist have a name? Not yet, it's just Robotanist, but I think you might be able to give it your own name whenever you play the game. What do you recommend as starting projects getting into game programming, such as this in C++ when already knowing C++? Just make whatever you want, even if it's like, you know, yeah, make whatever game seems like it would interest you, as long as it's not going to be too large of a project, I think. What are your opinions on GitHub Copilot? I think treating GitHub Copilot looks like it spits out code that shouldn't according to proper licensing. So that's pretty bad, basically. And from what I've looked at, it doesn't look super helpful. At least I don't think it looks too helpful for my usages, at least. What about SFML? I've never used it. Advice for people learning OpenGL? Use Stack Overflow a lot. Just try and fail, basically. Trial and error. Learn stuff. Win Batman 2 soon. Actually, I haven't seen the newest Batman movie that came out. Thoughts about Carbon? It looks interesting. It doesn't really look like anything that I would use. I don't have aside from this, I don't have massive code bases that need to be moved from C++. Like, it looks more like a corporate tool to me than, you know, a programming to like transfer from large code bases from C++ than anything else. Anyway, though, I think that's going to be everything for my stream. I kind of got to go now, but thank you everyone for tuning in. Thank you everyone for watching. I'll see you in the next video. I hope you enjoyed the stream. Yeah, and I hope you enjoyed watching all of my handmade explanations of trying to animate a robot and everything. So throw a dab emoji in the chat if you would like more streams in the future. But yeah, I'm just gonna go back to the starting screen. Thank you everyone for watching.